Discuss radicals. Compounds with ionic bonds have two constituents. These are cations, positively charged ions, and anions, negatively charged ions. They take part independently in chemical reaction and are therefore called radicals. These cations and anions, they take part independently in chemical reaction and are therefore called radicals. Now let's discuss chart. Complete the table. Base NaOH. First we will write the cation and anion. Na plus, and what is anion here? OH minus. Cation is Na plus. KOH. Cation K plus, anion OH minus. CaOH twice. Cation Ca 2 plus. And what about anion? OH minus. CaOH twice. So cation Ca 2 plus and anion OH minus. Acid HCl. Cation H plus, anion Cl minus. HBr. Cation H plus, anion Br minus, and HNO3. Cation H plus and anion NO3 minus. So here we can see here cations Na plus, K plus and Ca2 plus. Here cations H plus, H plus, H plus. And here anion Cl minus, Br minus, NO3 minus. Now we will discuss radical in detail. It is seen from the above chart that different bases such as NaOH, KOH are formed when various cationic radicals are paired with different anionic radical hydroxide. So cationic radicals Na plus and K plus, they are paired with different anionic radical hydroxide OH minus. Hence cationic radicals are also called basic radicals. Very important. Again I am repeating, cationic radicals are also called basic radicals. Different bases are distinguished from each other by basic radicals in them. On the other hand, different acids such as HCl, HBr are formed when different anionic radicals are paired with cationic radical H plus. So anionic radical Cl minus and Br minus are paired with different cationic radical H plus. Therefore, anionic radicals are also called acidic radicals. So, you have to remember this always. Cationic radicals are also called basic radicals. And anionic radicals are called acidic radicals. Difference in composition of various acids becomes clear from the acidic radicals present in them. Now, generally basic radicals are found by the removal of electrons from the atoms of metals such as sodium, copper. So Na plus, Cu2 plus, they are metals. Okay, so generally, but there are some exceptions such as NH4 plus. Exceptions are there. Similarly, the acidic radicals are found by adding electrons to the atoms of non-metals such as Cl minus, S2 minus, chlorine and sulfur, non-metals. Okay, but there are some exceptions like MnO4 minus. Monoatomic radicals such as Na plus, Cu plus, Cl minus are called simple radicals. Na plus, Cu plus, Cl minus, monoatomic radicals. Okay. When a radical is a group of atoms carrying charge such as SO4 2 minus. So, group of atoms, we can see here sulfur and oxygen. Okay. Atoms. So, SO4 2 minus. And one more example, NH4 plus. Here nitrogen and hydrogen. Both are there. A group of atoms carrying charge. It is called composite radical. So, simple radical, monoatomic radicals such as Na plus, Cu plus, Cl minus, etc. And when a radical is a group of atoms carrying charge like SO4 2 minus, NH4 plus, so group of atoms are there here. Okay, it is called composite radical. Is that clear? The magnitude of charge on any radical is its valency. We have already seen valency. The magnitude of charge on any radical is its valency. Chemical formula of compounds. Now we will discuss. The characteristics of a compound formed by ionic bonds is that its molecule has two parts. These are a cation and an anion. That is a basic radical and an acidic radical. So I have already discussed basic radical and acidic radical. So, basic radicals means cationic radical and acidic radical, anionic radical. These two parts are oppositely charged. The force of attraction between them constitutes the ionic bond. The name of an ionic compound contains two words. The first word is the name of the cation and the second is the name of the anion. So, sodium hydroxide, suppose or sodium chloride, we can take simple example. So, cation sodium and anion chlorine, Cl minus. For example, the formula of compounds such as sodium chloride is written by writing the symbol of cation, that means sodium on the left and adjoined to it on right is the symbol of anion, Cl. Okay, Cl minus. So, cation Na plus and anion Cl minus. Now, the charges are not shown, though the number of ions is written as a subscript on the right of the symbol of the ion. Now we will discuss the steps for writing chemical formula. Step 1. To write the symbols of the radicals. So Na. So we are going to write the chemical formula of compound sodium sulfate. So sodium Na and sulfate SO4. For first step we are writing the symbols of the radicals. To write the valency below the respective radical. So here we can see 1. Na we are writing 1 and SO4 we are writing 2. These are the valencies of the respective radical. So this we should know. So in order to write the chemical formula of compounds, it is necessary to know the valency of various radicals. You can see that here. Now I will show you a chart where few basic radicals and acidic radicals are given. So we can find out the valencies from the chart. Now, second step to write the valency. Is that clear? Third step to cross multiply as shown by the arrows the number of radicals. So, here we can see cross multiplication. To write down the chemical formula of the compound. So, it will be Na2SO4 1. Actually, SO4 1. So, no need for writing that one. So, finally, chemical formula of the compound, we are writing Na2SO4. In order to write the chemical formula, it is necessary to know the valency. I repeat again. Now, the names and symbols along with charge of common radicals are given in chart below. So, this is the chart. Here we can see few basic radicals and acidic radicals. Read this 2 to 3 times. So, you will be thorough with basic radicals and acidic radicals. Now we have finished all the topics in this chapter, measurement of matter. Thank you.